Alright, so in this second video we're going to talk about polynomials. We might recognize and remember polynomials as looking something like this. Alright, so this is what we would say is a first degree polynomial, but we can keep going, and basically what we're doing is we're just going to we got the same x term, but we're going to increase the power. We can keep going. Okay, we can keep going and going and going. So this would be a third degree polynomial. Okay, so we know individually, we should know how each of these things kind of looks like. This would be a straight line, right? This could be a right side up or upside down parabola, and this actually has an inflection where it's concave at one point and convex at another point. So all these different things are kind of coming together, including x to the 0, x1 to the 0, which is kind of how we can think about that. All these things kind of come together and give us an estimate of what y is going to be. Okay, so you might ask yourself, how in the world do we interpret these coefficients? Okay, so in order to figure that out, let's go back and just look at our simple linear regression case. Okay, so in this case, what we did in order to find what is the effect of x on y, we said, well, in order to find that, we're going to take the derivative of y with respect to x. In other words, we're asking, how does y change as x changes? Okay, so in order to do that, we're going to take the derivative of each of these components at different places. Okay, so this beta 0, if we take the derivative of beta 0 with respect to x1, we're going to get 0. Okay, basically the derivative of a constant is nothing. It's a constant, so it doesn't have a rate of change. Okay, so that would be 0. So we're just going to leave this out. Now, if we want to do the derivative of beta 1 x1 when it comes to in terms of x, then we're going to take away this x, or make it x to the 0, and we're left with a constant that's attached to it, beta 1. Okay, so that's how we are able to say that the effect of x on y is beta 1. Okay, we're going to do the exact same thing when it comes to a polynomial. Okay, so let's do a simple one here. So let's say we've got y equals beta 0 plus beta 1 x1 plus beta 2 x1 squared. Okay, so we want to know, what's the effect of x on y? Well, the derivative in this case is not going to be so easy as you might predict. So we're actually going to call this the marginal effect when we're going to do the exact same thing. And the reason we're calling it the marginal effect is because the effect of x on y is going to depend on the value of y. Okay, so I'll show you what I mean. Let's do exactly the same thing we did before. So we want to take the derivative of beta 0 with respect to x1. Again, it's a constant, so it's just going to be 0, so we'll leave it off. But now let's do this next one. Derivative of beta 1 times x1 with respect to x1. That's just going to be beta 1 again. Okay, but now we have beta 2 times x1 squared. Okay, so the derivative of beta 2 times x1 squared, first we're going to bring this 2 down to the front, okay, and then we're going to subtract 1 from that exponent. Okay, so we're going to have 2 beta 2 times x1 to the 2 minus 1, or just 1. Okay, so we're saying here that the effect of x1 on y is beta 1 plus 2 beta 2 times x1. In other words, it's a function of x1. Okay, so how much x1 affects y depends on the value of x1. Okay. Now another thing that you might find interesting is that because of this relationship, again, we might see, let's go back up to the last lecture stuff, we might see data that looks like this, okay, where the actual data maybe is some sort of a parabola, it's concave for sure, but maybe it looks a little something like you've seen before with a parabola. All right. So what's interesting about that is that maybe if we might be interested in where y gets maximized. So maybe there's some value of x that maximizes y, and we'd like to know what that value is. So in order to do that, what we could do is we could take the fact that the slope here, the slope at the maximum is going to equal 0. Okay. Now you got to be careful when you're doing this sort of thing, because what if the actual curve looked like that, and you used some more polynomials? You got to be careful if you use more polynomials that you're not finding like the min instead of the max, right? But we're not going to get that complicated in this class, okay? So basically what we got to do in order to find some maximum value is we're going to say, assuming that this beta 2 is negative, and thus we would have an upside down parabola as this part of the equation. So assuming that, then what we could do is we could find where the slope is equal to 0. Now, the derivative of this function is effectively the slope. Okay, so this is what we want to do is find where does this equal 0. So all we've got to do is set it equal to 0, and then if we can do that, and let's say assume again that we've run some sort of a regression, and we actually have a number for this and a number for this. Well, 2 is a number itself, so the only thing that's not a number is x. So we can just solve for x now, and we could find some optimal level of x that would maximize y. So that's a neat little trick. So I suggest whenever you're doing these that you kind of write out your full model. Okay, write out your full model, and whether or not that's one we've just kind of looked at, or one even with an even higher polynomial. Just write your full model out, and when you're finding the marginal effect, just take the derivative with respect to the variable in question, and you should be able to find your answer that way. So really it's really very similar to what we've already done before. We're just adding a little bit of spice to it. All right, well, thank you very much, and we will continue this lecture on nonlinearities. We're going to take a brief break to talk about dummy variables, because we're going to, in our next part on this series, we're going to incorporate dummy variables, and we haven't talked about that yet. So we're going to talk about dummy variables next, but we're going to return to this for a third part. And in this third part, we're going to talk about interactions between other variables. So maybe variables can interact together and affect y. So stay tuned for that, and I'll see you then.